Today it's still going to be factoring a difference of two squares. Here's example number 1. You have x to the third minus 49x. What you have to do is, if you don't have a difference of two squares, this is not a perfect square and this isn't either. See if there is something you can factor out from both terms. You can take an x out of both of them. So if I take an x out of x to the third, I'm left with x to the second. If I divide 49x by x, I'm just left with 49. So once you get to this point, you have a difference of two squares. So once you have a difference of two squares, you need the square root of this one and this one. 49 would be a 7. So that would be plus and then minus. So your final answer is x times the quantity x plus 7 and times the quantity x minus 7. This one is x to the fifth minus 9x. Now clearly this isn't a perfect square, and this isn't either. 9 is a perfect square, but when you have an x with it, it's not a perfect square. You can factor out an x from both of them and have x to the fourth and then minus 9. When you do that, you do have a difference of two squares there. So the square root of x to the fourth is x to the second, and then the square root of 9 is 3. X times the quantity x squared plus 3 times the quantity x squared minus 3. Give this one a try and drop it off. On this one, 3x to the third and 27x, neither one of those are perfect squares, but you can factor out something from each of them. You can take out a 3 and an x. When I divide 3x cubed by 3x, I'm left with x squared. And I've put an extra set of parentheses in here by mistake. I just need to scratch those out. There we go. And then when you divide 27x by 3x, then you have 9. So this is a difference of two squares now. So keep your 3x, and now you need two sets of parentheses. You'll have an x and a 3 in each one. Alternate plus and minus. This should be familiar. It looks similar to a homework problem. On this problem, you can take out a 5 from both of those, as well as an x. Factor out 5x, divide 5x to the third by 5x, and be left with x squared. And then 125x divided by 5x is just 25. Keep the 5x, and you have a difference of two squares here. The square root of x is x, and the square root of 25 is 5. Alternate the signs. In this example, it's x to the seventh minus 81x. You can take out an x from both items and be left with x to the sixth minus 81. Okay, we do have a difference of two squares because x to the sixth, its square root is x to the third. If you multiply x to the third times itself, you add the exponents and get x to the sixth. So that works out, and 81 is a perfect square. You end up with a 9. Alternate the signs, and that's your answer. And for this one, you have x squared plus 25. What do I do first?
You can find the perfect squares because they're both perfect squares.
No.
You need an x.
No.
Oh, you have to make it a subtraction problem.
Well, you can't do that.
There has to be a minus sign or whatever.
No.
It's a sum of two squares. That's not possible. So when you see one like that, this is the answer.
Wait, you can get
On this one, you can take out an x from both of them, and that's x to the fourth minus 25. You do have a difference of two squares. The square root of x to the fourth is x to the second, because x to the second times itself is x to the fourth. And then you have minus 5 and plus 5, alternating signs. You can factor out an x from both of them and be left with x squared minus 81. And you have a difference of two squares. The square root of x squared is x, and of 81 is 9. And then alternate the signs.
So you're not all